Hello everyone, welcome to Mayur Programming Club. Today we will be solving another daily LeetCode problem, and the problem's name is intersection of two arrays. So according to the problem statement, there are two integer arrays which will be given to you. You have to return an array of their intersection. Okay, and each intersection in the result must appear as many as times as it is shown in both of the arrays. For example, in the first example that is given to us, 2 was appearing twice in both of the arrays, so in the intersection also it appeared twice. Okay, and you can return the result in any order. And let's have a quick look at the constraints also before thinking of an approach. So according to the constraints, the length of the both of the arrays will be of order 1000, and each entry in these arrays will be ranging from 0 to 1000. Okay, and there is a follow-up also. So what if the given array is in sorted order? So if the given array is in sorted order already, then how we will optimize our algorithm? And it is then again stated that if what if the first array's size is smaller than the second array's size, so which algorithm will perform better? Okay, and then there is again uh, further in the follow up, which is what if the elements of the second array are stored on a disk and the memory is limited such that you cannot load all the elements in the memory at once. So we will try to address these follow ups also in our approach. So let's discuss that. So a very intuitive approach that is coming to my mind is we can just use some extra space. Okay, this is the extra space that we will be using other than the space required to store the intersection. Okay, so extra space can be used, and we will use a data structure which is known as hash set. So it will store all the or hash map actually, because there may be elements occurring twice, so we can use the hash map to find out which elements are occurring. And then because of use of this extra space, we will be able to solve this in a linear time complexity which is order of n. So what we will do, first of all, you will be having two arrays, nums of 1 and nums of 2. Okay, and you will have a hash map. So frequency map, so it will be number and its frequency. So for example, here 1 was occurring twice, 2 was occurring twice. Okay, so in a way it will be something like this. Then you will be having frequency map of second array if you are considering this input. Okay, so let's take it to the board. So if we consider this as our input, then you can see that for the first array we have already made the map. Then for the second array we will again make the map. So here 1 is not occurring any number of times, so this is the number and this is the frequency for nums2. So you can name them. This is for nums1 and this is for nums2. Okay, and then simply you will check what is the commonality between them, or what is the minimum frequencies of the common elements. Okay, and then they will consist of intersection. If let's say 2 was occurring thrice here, okay, then we would have only took 2 as our frequency, because the minimum number of times is that much, so the intersection will be that only. Okay, so this is one approach of using extra space. But in the follow up, they were saying that what if the array is already sorted, and what if both arrays are not of same size. And the third condition that they imposed was that what if the elements of the nums second array were stored on a disk, and the memory of the disk were limited, such that we cannot load all the elements at once. So what we should be doing that in that scenario, we will be using two pointer approach in that scenario. First of all, although the arrays will be not be sorted, but they were trying to make us consider a scenario. For that, we will first of all make the two arrays sorted. Okay, so first of all we will sort the two given arrays. Okay, and after we have sorted the given arrays, what we will do, then we will have two pointers. So the sorted form of the first array will be this, and the second array will have its sorted form as this. Okay, then you will be having two pointers pointing starting from the very left of both of the arrays. And if the element pointed by the first pointer in the first array, or let me take the code also so that it will take us less time to explain. So let's bring it here. So this is the code. So what is happening here is, first of all we sorted the arrays as we discussed. Okay, then after sorting the arrays, we initiated a common list that will be storing our common elements, and then we initiated two pointers, which is index 1 and index 2. So this is index 1, index 2, and this is index 1. Okay, pointing to the indices of these arrays. Okay, and then if the first number, the number pointed by the index 1 pointer in the first array is less than the number pointed by the second pointer in the second array, then in that case you will increment this pointer to one position ahead. Okay, this is that case. And if there is a case that this particular number is lesser than the entry which is being pointed by the first pointer, then you will increment the second pointer. Okay, whenever whichever pointer is pointing to the lesser number, that pointer is being incremented by one place ahead towards right. Okay, so this is what is happening here. Then what we will do, if there is a common element, it means that both pointers are pointing to the elements which are equal. In that case you will store that element into the common list and increment both of the pointers to move one place ahead. Okay, so this is the whole algorithm, and at last you will be returning your common intersection. Okay, and as far as the time complexity and space complexities are being concerned, time complexity wise, you can say that if we are not considering the sorting, if the arrays are already sorted, then you will be taking order of n time complexity. But if you consider sorting, then this time complexity will not be order of n, it will be order of log of n. Okay, if you consider sorting, the arrays are not already sorted. Okay, and if you are not considering the space that will be used to store the common elements, in that case the overall space complexity for this particular algorithm will be order of 1, which is constant. Okay, but if you are considering the space complexity which will be required to store the common elements, in that case it might be order of n. Okay, because of use of this extra space that we are considering. Okay, so although given the, if we consider everything, the sorting and the use of extra space for storing elements, then these will be the complexities. Okay, and Yeah, that's pretty much it. If you are still having any doubts or any queries in general, then you may ask them in the comment section. Thank you for watching, and I hope this solution video added some value to your journey of honing your DSA skills. Till then, keep practicing and keep solving more problems. I will see you in the next video. Thanks for watching.